Good morning, ladies and gentlemen. Good to have you in Precalculus today. We're going to go over this exercise set of 17 through 20 and 25 through 28, which is on the heels of what we talked about on Friday. And so, can you see some of the same vocabulary in this exercise set here? You should. We talked about roots and zeros, right? Well, x-intercepts, that's synonymous. So you're going to be able to graph this in a viewing window that shows all the extrema and x-intercepts. Now, as it turns out, what are the zeros of this function going to be?
9, -2, -3.
So Robert says our zeros are going to be x equals 1, x equals -2, x equals -3. So we graph this now. When we graph this in our calculator, and if I could draw a vertical line, say, wouldn't that be dangerous? Here we go, that's more or less vertical. So yeah, so Robert is exactly right.
Please excuse this interruption. At this moment, will you please log out of your gradebook? Texas is fixing to do an update, so it will be down for a little bit. If you will log out at this moment, and we will let you know when it's back up. Thank you.
So I can log out. How do you log out of this thing? Usually it just times out. Log out. Yeah, there we go. There I did. Okay, did it. And what you do is that I know the exercise here is supposed to be really on using the calculator, but here we have our zeros marked right here at -3, -2, and at 1. And what you do is you look at the nature of the function, and when you multiply all these x's together, what are you going to get? X times x times x. You're going to get x cubed. And so the nature of the function is going to be odd because we have an odd degree. So it's odd natured or odd degreed and positive. So an odd positive polynomial function is going to start where? It'll start low and then high. Okay, so that's what we're going to do. And we know if we start low, and end high, we're going to go like this. Start low, come up here, multiplicity of 1, we go right through, come here, and then we're going to come like this. That's what things going to look like. And then in the calculator, x minus 1, x plus 2, x plus 3. X minus 1, x plus 2, x plus 3. And we graph, if we go to standard window, it looks something like that. Is that what you have for that? Is that, Corinne, is that what it looks like? And so really this is a standard graph in the standard window, and basically we have all the x-intercepts, all the extrema. We see the relative maximum, the relative minimum there. And what about the end behavior? How do we talk about end behavior in this class? Well, limit as x approaches infinity of f of x. What does this equal as x approaches infinity? F of x approaches also infinity. And limit as x approaches negative infinity of f of x is equal to negative infinity. Okay, so these will be our answers for problem number 17. So that's it. Any questions on this one? Looks pretty straight. So I want you to go ahead and take a look at number 18. Number 18 is a similar looking problem. Ooh. Now I'm bringing back a little bit of vocabulary from last Friday. What is going to be the multiplicity of each of these zeros? Multiplicity equals 1. Do you see that? Zeros happen one time. Thank you, Karina. Yes. And is this going to be odd-natured polynomial?
Yes.
Yes, it is, because we're going to have, when we multiply all the x's together, we're going to have what? At cube, x times negative x times 2x. We have negative 2x cubed. Is that going to be odd positive or odd negative? Odd negative. So we're going to start where? Yeah, so Elizabeth is pointing with her left hand, which corresponds to my right hand, right? We're going to start high and end low.
Yes.
Right. So we're going to start up here in quadrant 2. We're going to end down here in quadrant 4. And do we know from this exactly what's going to happen? Well, we can figure it out pretty simply. So now we have these zeros here. It's a little better. XY. So we have 3 over 2. We have 4. And we have negative 1. And so we're coming, we know odd negative. Okay, let's go ahead and fill that, because Elizabeth is asking a good question. Let's go ahead and dial it back. So if we solve this equation, we add 3, we get 2x is equal to 3, dividing by 2, x is equal to 3 over 2. Okay? Now what Elizabeth asks, and that's a good question, is this, it can be a little bit counterintuitive, because if you look at the factor, the value of the 0 is positive, even though the factor itself is 2x minus 3. So, did that answer your question? Okay, yeah, that's a good question. So we're going to start high and end low. So we start high, and we know our multiplicity of the zeros is 1, so we're going to go like this. And I don't know what kind of a window you came up with this, for this, but yeah, it looks pretty good. So we have 2x minus 3, 4 minus x. 2x minus 3, 4 minus x. And then it was x, whatever it was, plus 1. So here, is this what you got for it? What you got for it? Yeah. The only thing is, does the window quite get everything for us here? Not quite. So if we make some minor adjustment to our y values, we can probably get everything all right. Okay. So all I did was I changed the y minimum to negative 15, the y maximum to 15. All right. And we can see the extrema, see the zeros, see everything. And the limit as x approaches infinity of f of x is negative infinity, and limit as x approaches negative infinity of f of x equals positive infinity. Okay, so that'll be our answer. Now, on the next two, what we have is a situation where we're not given the function in factored form. And so that causes, so we can't really sketch it as easily, but do we know if this is odd positive, odd negative, even positive, or even negative? Yeah, we do. What is this going to be?
Even.
This number 3, is that an even number or odd number?
No, it's all.
Odd. So it's going to be odd positive or odd negative? Odd negative. So to me, this one here, it's a matter of adjusting your window to be able to see that, because we have a y-intercept like this that is going to be outside of your regular viewing window. So I want you to go ahead and play around with your viewing window on your calculator and tell me what you come up with, and then we'll proceed from there. Yeah, just let me go ahead and get some of these out. There's quality. What kind of a window did you get on this one?
For the X minimum, I put negative.
Negative, what'd you say?
Negative 20.
X minimum?
Yep. And 20 for the X maximum. For the Y minimum, I put 150.
Negative 150?
Yes. And for my max, I put 100.
100? Okay, I think that's similar to what I did in my video. I think I just left these at negative 10 and positive 10, but I think everything
Yeah.
else is the same.
I could have left.
That's all right. So we got negative
X
x cubed
plus 4x squared plus 31x
minus 7, minus 70. We graph. Yeah, so that gets everything here, doesn't it? And I'm going to just change this to make it maybe just a little easier to count. And I'm going to change my Y scale to 10. Yeah. And so we see our x-intercepts at negative 5, 2, and 7. So at negative 5, 2, and 7. And so the thing, and we have negative 70 as our y-intercept. It's negative 70. So we're going like this. What are going to be our end behavior? Limit as x approaches infinity of f of x is
negative infinity.
negative infinity, and then the limit as x approaches negative infinity of f of x is
Positive infinity.
equals positive infinity. Okay. All right. Okay, what I'm going to do for number 20 is have you do that one, and I'm going to call on somebody to give me a viewing window. I'm going to use my random name generator for the first time in class this year. You already have it worked out? Oh, you're working on it, okay. Okay, I'm gonna have somebody choose a window for me here. Use our random name generator. And we got Robert. You are the chosen one. We have a winner. That's you, Robert. What is your window for this one?
The x minimum is -10, the x maximum is 10. The y minimum is -125. The y maximum is 150.
Okay, let's try that out. So we get -125 and 150. Okay, and we come over here, and that's going to be x cubed minus 2x squared, is that right? X cubed minus 2x squared. And that's going to be minus, is it 41x
Yeah.
plus 42? And then we graph, we get, that's going to be the blue one. And is that one working here, the blue one? Yeah, that's good. Let me, for purposes of lessening confusion, I'm going to go ahead and just leave this one. Okay, it looks like a good window to me. Gets everything, gets our zeros and everything needed. All right. And what's going to be our limit as x approaches infinity?
Is positive.
Infinity, and limit as x approaches negative infinity of f of x is equal to negative infinity. Starts low, ends high. Okay. So pretty simple, just getting acquainted with your calculator pretty much. Now, the next part we have of the exercise set, to me, 25 through 28 is even more simple than the one we just came out of. We're describing the end behavior of the polynomial function. So basically, we need to look at this and analyze if we have odd positive, odd negative, even positive, or even negative. So for number 25, is that going to be an odd positive, odd negative, even positive, or even negative?
Even positive.
This will be even positive. And again, it's even natured. It's not necessarily technically an even function. But when we graph that, we don't know exactly what it's going to look like if we don't graph it. But we know it's going to start where and end where.
Start low and high.
No, it's going to start high, end high. So it's going to come like this, something like this. And we don't know exactly. We know the thing's going to start high and end high, but we don't know what the middle looks like exactly. But do we know from here enough to put down our end behavior? Yes, we do. Limit as x approaches infinity of f of x is equal to infinity, and limit as x approaches negative infinity of f of x is equal also to infinity. So this is going to be our answer for number 25. Did you graph that in your calculator too and take a look at it?
Yeah, I did.
And yeah, I know the middle is not exactly the same, but you don't have to have it that way. You can kind of write this, you can try writing this as a quadratic and possibly factor it without, even though it's a cubic, a quartic function. I think that's the one I got wrong on the video. So number 27, yeah, just go ahead and do it. Number 27, you just need to rewrite this in standard form. Just helps you to see it better, I think, if you do it that way. There's 27 and there's 28. Okay, 28 you need to rewrite too. But really, that's all there is to today's exercise set. Do you have any questions on these? Are y'all finished, Karina? So I'll give you the opportunity to finish these, and we'll just call that a wrap on this.